All right, so we are getting into our last section of notes for this unit. We're adding on another kind of theorem that we're going to use in these proofs that we're talking about, and we're still focused on the same concept of proving that triangles are congruent. We're just adding in an extra piece. So the date that we did this is the 21st, and our objective is we want to use what we've been talking about with proving that triangles are congruent, and then also this new theorem or property here called CPCTC. To help us add in some different piece of information. So first off, kind of reviewing a little bit here. If you would like to, you can sketch this triangle or this diagram, but you don't have to. So we just want to talk through this here. We're told that PR is congruent to TR, so I'll just go ahead and mark that. And then we're also told that QR is congruent to SR. And it's saying, if this is the case, explain how you know that angle P is congruent to angle T. Okay, so notice here, if I'm trying to think through this, if you'd like to, you can kind of test yourself and try to think through why would I know that those two angles are congruent? Because there's no given information that helps me figure that out. But we do know this, it's just in more of a roundabout way. So if I gave you just this and nothing else, and we did what we usually do with these kinds of proofs, we could prove that these triangles are congruent. Because we have two sets of sides, and then notice we do know that the angles in between them would be congruent by the vertical angles theorem. So the first piece I'm just going to write down here is I'm just going to say the triangles, or I'm going to say since the triangles are congruent by, remember this matches the side angle side theorem. Okay, so I'm going to say since these triangles are congruent by this theorem, then this leads me to another thing that we haven't really discussed when we've gone through these proofs, which is, do I know anything after this fact? Well, remember, if we say that two shapes or two triangles specifically are congruent, what that tells us is that tells us every piece of the triangles are congruent. We've just been working with shortcuts and just using, two or three pieces of information to help us prove this. But remember, once we show that, now we know all the pieces are congruent. So I would say since the triangles are congruent by side angle side theorem, angle P and angle T are congruent because they're what we call corresponding, or they're in the same spot, right? Okay, they're corresponding. And we know if we said that the triangles are congruent, then all the corresponding pieces are also congruent as well. Okay, so this idea leads us to this concept, theorem, whatever you want to call it, that we're going to talk about today, which is called the CPCTC. Okay, and the definition of this is actually just what it all stands for. So CPCTC stands for this. It stands for corresponding parts of congruent triangles. And here, I'll go ahead and capitalize all the important letters here. Corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are congruent. So for example here, if we're looking at two triangles that we know are congruent, so let's say we'll draw triangles ABC and DEF. And let's say we've proven that they're congruent because of one of the simplest theorems we have, the side theorem. So let's have one pair of sides, two pairs of sides, and three pairs of congruent sides. Okay, so usually in a proof we'd say these are congruent, side, and we're done. But now we're adding on an extra piece, which is, now that we know this, what other piece of information do we know? Well, since these triangles are congruent, what we know now is we know that all the angles, like for instance, angle A and angle D would be congruent, or B and E, or C and F, or so on and so forth. Okay, so this is the idea that we're kind of adding in here, an extra little step to make sure we fully understand congruent triangles. Okay, so first off, just a little example here. Okay, I'll give you a sec. I do want you to sketch this diagram for me, and I'm going to go ahead and actually cross out anything with X and W, because we don't need to worry about that. So here, is that going to be important? Where is W at? Maybe I did just cross out. Or no, Y and Z is what we're looking for here. So I'm going to cross that out, cross that out. Okay, don't need to worry about any of these extra things. All I need you to do is draw these two with these pieces of information here. Okay, so once we have these drawn, we're going to use these to solve for x and y, or I'm sorry, y and z. And notice here, we're told from the start that these two polygons are congruent. Okay, this is something that we did at the beginning of this unit, where we said I have two congruent shapes. So what do I know? I know all of the corresponding pieces are congruent. And notice how the letters line up. So B to R, C to S, D to T, and then E to U. So notice these shapes are kind of just flipped on each other. Okay, so if I want to set up an equation to solve for U, I see two different angles here, 2y minus 31 and y plus 11, and that's at angle D and T. Okay, and like the congruent statement says, D and T are corresponding, so that means I know they're congruent. So I can say 2y minus 31 equals y plus 11. Okay, so I set these two equal to each other, and then I would just solve. So multiple ways to do this. First thing I could do is I could subtract y from both sides. So I'd have 2y minus 1y. That's just going to give me 1y, or just y. And then minus 31 equals 11. And then last step we should know, add 31 to both sides. When I do that here, I get y equals 11 plus 31, and that's just going to give me 42. Okay, so y equals 42 here, final answer. Okay, so that's if I want to solve for y, and I'm just using corresponding parts. Okay, and then if I want to solve for z, I see the same kind of idea here. So notice I see that I have one side that's z, or with ed here, that's 3z plus 10, and I see ut here is z plus 16. And again, I can see ed, if I'm looking at the congruent statement, ed is going to line up with ut. So these two are corresponding, and again, since the whole thing, or the shapes are congruent, that means all the individual pieces are congruent as well. So I can just set these equal to each other, 3z plus 10 equals z plus 16. And just like before, we just solve like normal. So I could subtract z from both sides. When I do that, these cancel. I get 3z minus 1z. That's going to give me 2z. Okay, and then plus 10 equals 16. Continue to solve here. I can subtract 10 from both sides. When I do that, I get 2z equals 16 minus 10. That's just 6. And then last step here, divide by 2. And I get z equals 3. So using those same concepts that we talked about at the beginning of this unit, but now we're just adding that in as an extra step in our proofs. Okay, so let's take a look at how that'll change our proofs and what those will look like here. Okay, so looking at example 2 here, as always, if you'd like to, you can go ahead and take a sec and sketch this diagram here. And this is actually a diagram that we've seen many times now. And we're having different pieces of given information with them to prove that triangles are congruent here. So first thing I'm going to do is I'm going to go ahead and set up my proof. And again, make sure you have this drawn down. Okay, so I'm going to set up everything, statements, and reasons. Okay, I'll start with our given information. And I'll just go ahead and copy those down. So we're told two things here. We're told BD bisects angle ABC. Okay, we're told BD bisects angle ABC, and then we're also told that BD is, remember this symbol means perpendicular, so BD is perpendicular to AC. Okay, so that's just from our given information. And notice the big difference between these proofs and any other proof is my prove statement, or what I'm trying to prove is not that the triangles are congruent. Okay, what I'm trying to prove here is that AB is congruent to CB here. Unfortunately, we're not given any given information that would help us prove that just directly. So what we're actually going to do is we're going to do the same thing we have been. We are going to prove that the triangles are congruent, and then we're just going to add in this last step here. Okay, so let's go through the same process we always do, trying to prove that the triangles are congruent. So for instance, we look at the given, and we see BD, we're told bisects that angle ABC. So remember, if I take this whole angle ABC and I bisect it, or I cut it in half, I'm going to have two equal halves right here. So I just need to name these here. These two congruent halves are going to be angle ABD, and that's going to be congruent to angle CBD. Okay, and again, I make sure that I line them up correctly so that all the letters are in the correct spots. They correspond to each other. Okay, so I have this here, ABD and CBD, and the reason for that, or how did we know that? Remember, that came from the fact that it was a bisector. So this would be definition of, and since it was bisecting an angle, I'm going to say definition of angle bisector. Okay, so that's always our first step. I'm looking at what do I know from the given. Okay, so we have those two angles are congruent, and I can go ahead and mark those as well. Put one arc on each of them. Okay, we also have another piece of given. We're told BD and AC are perpendicular, and as I mentioned, we've seen this before in notes. Okay, if this is the case, if we're thinking about perpendicular means, remember those are two lines that intersect, and this is actually marked on the diagram for you. These are two lines that intersect at a 90-degree angle. So what I can say here is I'm going to say angle, these two angles here, ADB, and the other one, angle CDB, are right angles. So I'm simply just stating it out, and you always need to state that out first. Okay, I know that, or how did I get that? Remember, that's from the fact that those lines were perpendicular. So I'm going to say definition of perpendicular lines. Okay, definition of perpendicular lines. Okay, and I'll go ahead and mark that as well. One of them, like I said, is already marked. We'll mark the other one. That's also a right angle. And as I mentioned, this was actually on our last notes when we did hypotenuse leg, and we actually have two choices here. Either we can use this statement that we just made, the fact that they're right angles. We can either say two things. One, I know the angles are congruent because they're both right angles, they're both 90. Okay, or I can say that these triangles are both right triangles, and then that would lead me to using the hypotenuse leg theorem. So trying to determine which one of those I'm going to use here, well, notice I'm not told any information about either of the legs of my triangle, or at least I do have one of them, I guess, or I will have one of them. But I don't have any information about the hypotenuse of each right triangle, because actually that's what we're trying to prove here. So since we're not going to figure that out until the very end. What that means for us is we're not using hypotenuse leg, so we don't need to say that they're right triangles. What we do need to say is that angle ADB is congruent to angle CDB. Okay, you can list both because they're both true. You could say they're congruent and you could say they're right triangles, and then just try to dissect from there which one's going to be helpful. But if we are looking ahead in our proof and trying to figure out which theorem we're eventually going to use, if we're not using hypotenuse leg, then we don't care if the triangles are right triangles. Okay, so these are congruent, and my reason for this is one of these weird ones that we've talked about before. This is the only time you'll pretty much just write out a sentence, and all that sentence says is all right angles are congruent. And I go ahead and abbreviate as well. But all right angles are congruent. They're all 90. They're all going to be congruent to each other. Okay, so now we've got two pairs of angles, and now we just need one more step. So once we've covered our given, we always look at our diagram, and we've seen this idea time and time again. If we see a shared side here, which in fact we do, then I can say that it's congruent to itself. So I'm going to say DB is congruent to DB. Okay, DB is congruent to DB. And my reason for that, or why is that the case, remember we've talked about this a bunch, this is the reflexive property. The reflexive property here. Okay? And now that I've answered those two questions, usually a good question to ask is, do I have enough information? And in this case, I do have enough information to prove that the triangles are congruent. So I'll go ahead and say this. I'll say triangle, and I'm going to make sure that everything is lined up correctly. I'll say triangle ADB is congruent to triangle CDB. And my reason for that, or what does this match? Well, notice here I have two sets of angles that are congruent and the side in between them. So this is angle, side, angle theorem. Okay, the angle, side, angle theorem. Okay? But like I mentioned, that's not what we're trying to prove, right? What we're trying to prove is that AB is congruent to CD. So we need to show that the triangles are congruent first. So we've done all the work that we usually do, and now all we're going to do is add on one last step. So our last step here is now we can say what we're trying to prove. AB is congruent to CB. Okay? I know that's the case, and my reason for that is since I've shown that the triangles are congruent, then all the little pieces, the corresponding pieces, are also going to be congruent. And we can kind of abbreviate that as CPCTC. Corresponding parts of congruent triangles are going to be congruent. Okay, so that's essentially what we're doing. We're just adding on this step here to show that triangles are congruent, or show that pieces specifically are congruent. Okay, so let's practice that one more time here. And we'll be good for today, kind of seeing how this can be used in a proof. Okay, so again, example 3, a little bit more of a complicated one. I'll give you a sec to go ahead and sketch this. And we're told two pieces here, so I'm going to go ahead and set everything up. Okay, statements and reasons. I'll just go ahead and copy down what's in my given. So I'm given two things here. I'm given a pair of angles that are congruent. So I can say angle DAC is congruent to angle BEC. Okay, and then we're also told that line segment DC is congruent to line segment BC. So just copying down all of that in our given. And one other recommendation I like to throw in there as well is if you have any angles or sides that you said are congruent, go ahead and mark those here. So if I look at DAC here, okay, so I'll go ahead and say this angle is going to be congruent to angle BEC. So I'll go ahead and mark it. I'm going to mark it a different color, and I'll show that why in just a second. Okay, and then we also have DC, so this side length here, okay, notice that right here, is congruent to BC. So I'll go ahead and mark that with one dash mark as well. Okay, and so notice we are trying to prove again that two pieces are congruent, so not necessarily the triangles. And so if we're trying to figure out which triangles I'm trying to prove are congruent, I would just look at the letters I've been given so far. So DAC, let's just make that our entire triangle, DAC. Okay, so we're saying DAC is supposed to, and I'm just getting it from up here, okay, is supposed to correspond to BEC. So I'll go ahead and outline that as well, BEC here. So notice these are two triangles that are essentially overlapping. And so actually I'd have to take one and kind of reflect it or flip it upside down for those to line up. But we still know which letters are corresponding, D to B, A to E, and then C to C. Okay, so we can use those here. Okay, so we actually have a lot of information. If I'm just looking at these two, I have a pair of angles already, and then I have a pair of sides. And so we actually only need one more piece of information. Either we need to say another pair of sides are congruent, or we need to say another pair of angles are congruent. So we go through our process. The first question, do I know anything from my given? In this case, those two pieces of given information have kind of already done their job. So now we just need one more piece of information. So if I'm trying to figure out what that would be, okay, the second question is, what do I know from my diagram? And if I'm looking at my diagram here, this one's a little bit tougher because there's not really a shared side. You know, there's sides that are overlapping, but it's not like they're the exact same sides. Because for instance, if you look at the green triangle, I have this side length DC here, and in the red triangle, it's the whole thing EC. So it's not the whole thing, it's just pieces of it. And then same thing, there's no other sides. Okay, another piece here that I could look for is vertical angles, but unfortunately there's not any vertical angles between the two triangles. Okay, there are little vertical angles in this picture, but they don't make up the entire triangle. So this last piece here, is there anything else that's shared between them? Because usually we know it's either reflexive property or vertical angles, and in this case it is. We are actually going to use one of those. It is the reflexive property. And notice we don't have a shared side, but what we do have is we have this angle here that's in both of the triangles. Okay, angle C is a part of both of the triangles there. So what I can say here, to put it simply, is I can just say angle C is congruent to angle C. Okay, this is an idea that we haven't seen before, but it actually does work in this case. Okay, just like the same side would be congruent to itself, since I have the same angle in both of them, the same angle is also going to be congruent to itself because of the reflexive property. So like I said, a little bit tougher of an idea to see, which is why we're throwing it now. But still can use the reflexive property. Something's congruent to itself. And now I actually do have enough pieces of information, so I'm going to go ahead and write this out. So I can say the triangles, so triangle, let's just say DAC is congruent to triangle BEC, and I'm just getting these letters from my given. Okay, and what is my reason for that? It's a little bit tougher to see when they're overlapping, but if I just draw this green triangle out here, notice we said this angle, and then this side. So this would actually be angle, angle, side here. So as we've seen before, if I have two shapes that are overlapping, sometimes it helps to kind of draw them separately or kind of away from each other so that I can really zone in on what theorem I need to use or what piece of information I have. Okay, and then like we mentioned, this isn't what we're trying to prove, so I do need to add on one more step, and I can just go ahead and tack that on to the end. So I'm going to say angle ADC is congruent to angle EBC. And my reason for that, like we mentioned before, since I showed that the triangles are congruent, then all the corresponding parts are also going to be congruent here. Okay, and I do need to check and make sure they're corresponding. Angle ADC, so right here, and then angle EBC right here. And those would in fact be corresponding. So those would be congruent. Okay, and now my proof is done. Okay, so we're just adding on this extra step to all of these proofs here. Okay, so still the same process, just make sure we throw in CPCTC at the end. Okay, all right, assignment for today is just going to be 6.5 homework, CPCTC. And as always, if you guys have any questions, feel free to let me know. All right, thanks guys.